Our study was a replication of Norman's 2008 study called Increasing Physical Activity Through Self-Monitoring, Goal Setting, and Feedback. The participants in our group included Sarah Garner, Lauren Scholes, Joanna Sita, Katie Sova, and Kendall Stubelt. Our literature review included 5 different studies that discussed the behavior of physical activity and or the intervention of goal setting and feedback. In a 2016 study by Eck, Miltenberger, and Van Buna, the purpose was to evaluate feedback, goal setting, and rewards that were administered by the parents of 5 typically developing but overweight children to promote physical activity. The target behavior in this study was the number of steps that were recorded on the pedometer. The goal was first considered for each day, and rewards were delivered contingent upon meeting the specific step goal. The reinforcers were chosen by the parents and children so that the parents could provide them daily at no cost. The reinforcers were used in hopes that the behavior change was more likely to generalize and be maintained after the research was complete. For 3 of the 5 participants, goal setting and rewards increased their steps. However, there were other prompts used to further increase their steps. The parents found the intervention to be very time-consuming and effortful, which may cause them to not maintain the rewards or goals. The study also concluded that the increase in steps was moderate and highly variable. A second study called Increasing Physical Activity of Children During School Recess was conducted by Hayes and Van Camp. The Centers for Disease Control and Prevention suggests 60 minutes of moderate to vigorous physical activity for children per day. This study used reinforcement, self-monitoring, goal setting, and feedback on 6 elementary students. The purpose was to determine if this intervention package could increase steps during an unstructured recess time. A Fitbit was used to collect data, and a preference assessment was used to determine effective reinforcers, which made this study different from others using these interventions. The results show a clear increase in total steps taken. All goals were exceeded. The moderate to vigorous physical activity levels increased during intervention phases as well. Next, the purpose of a study called Stickers for Steps by Morrison and Bakov was to look at the social aspects of tracking physical activity. An activity tracking app, Stickers for Steps, was designed to encourage face-to-face encounters and interactions. The app was created around the idea that social relatedness is a primary psychological need that is crucial to motivation. A system was designed to not only reinforce physical activity among users, but also create a community where meetings between users were encouraged and so were real-world discussions. The application was trialed for a week during 2016. They found that users averaged 5,588 steps daily. In addition, log data reported that 95.5% of stickers were opened throughout the intervention. In post-intervention interviews, users responded positively, with 84% reporting that they felt motivated by the stickers. And applications such as Stickers for Steps could act as motivation to encourage more activity in addition to allowing social interaction and positive encouragement. Next, the study using goal settings and feedback to increase weekly running distance used a treatment package of self-monitoring, goal setting, and feedback to increase the running distance for a group of 5 adults. Each participant met with the researcher to set 3 goals a week with criteria levels that had to be met to move to the next goal. Feedback was provided in the form of verbal descriptions, and graphic displays. All 5 participants were successful in increasing their running goals. Results show satisfaction among participants for reaching their goal and increasing them a little over time. Results also indicate effectiveness of the treatment package. Lastly, an article by Wilson, Sibthorpe, and Brusso used 3 different goal-setting interventions using pedometers to determine the level of enjoyment that the participants felt towards physical activity. During week 1, baseline data on step count and enjoyment were collected. During week 2, individual step goals were set. In week 3, small group set goals were set for step count together. Then in week 4, the entire camp set a goal to meet. Kids at the camp filled out a funometer, which is a 10-point Likert scale in which the participants were able to rate how much fun they had, with 10 being the most fun and 0 being the least. The camp-wide goal week revealed that both the step count and enjoyment from the participants showed significant improvement compared to baseline. The study indicated that the goal-setting interventions did increase both the level and enjoyment of physical activity, and also found that boys typically had a higher step count than girls. The results also revealed that the older participants recorded less enjoyment for physical activity. Our original study had an intervention package of goal setting, self-monitoring, and feedback used to increase the likelihood of physical activity on a daily basis. They used 4 participants wanting to increase daily activity levels. It was tracked using the number of steps the participants took on a daily basis using a pedometer. Daily step goals established using the averages for the previous week. The researcher used local verbal feedback and graphic displays and provided praise and encouragement. Results showed variable data. There were 3 of the 4 participants increased daily step count but maintained their weight.
Next, we'll talk about the purpose of the project. In the 2008 study by Normand, all of the 4 participants in the study showed a functional relation between the independent and dependent variables. All participants showed an increase in daily step count contingent on the presentation of the intervention, showed a decrease back to baseline levels when the intervention was removed, and then showed an increase in daily step count when the intervention was reintroduced. The purpose of our replication study was to determine if the treatment package of daily monitoring, goal setting, and peer feedback that was used in the original study would have a similar effect on each group member's daily step count. As a group of similar healthy adults, our project sought to determine if the same treatment package of interventions would yield similar results when replicated with a similar population.
In our study, the participants are 5 adult females attending Ball State University's graduate program. Each participant identified interest in increasing their daily activity prior to participating in the group behavior change project. The participants' ages ranged from 23 years old to 22 years old. The setting took place in each participant's home and community. Materials involved included a pedometer, Fitbit Flex, Samsung Gear, or other tool to measure steps taken daily. In addition, participants needed access to a phone or computer to contact their partner in order to receive and provide feedback daily. A permanent product recording system was used to record the number of steps taken daily. For the purpose of the study, a step was defined as any activity that resulted in a step count being recorded on the pedometer or step tracking device. Throughout the intervention, each participant was required to track their steps until 8 p.m. daily and take a picture of their pedometer each night. Reliability measures were conducted throughout the daily self-monitoring and daily message feedback between partners. Permanent products in the form of text messages between participants were used to record the occurrence of daily reporting and feedback between partners. Reliability was calculated by dividing the number of days that the participants reported their daily total step count to their partner during the intervention by the total number of intervention days and by multiplying by 100 to get a percentage. The experimental design, the study was conducted using a multiple baseline across participants' design. In addition, A-B reversal was conducted. Baseline data was derived from a count of daily steps. Each member logged their daily steps into their table for at least 7 days of baseline. Once baseline data was stable or decreasing, the participants began their intervention. If baseline data was variable or increasing, then baseline data continued to be taken and monitored until it was determined appropriate to begin the intervention. During intervention, each group member sent their daily step count to their assigned partner. This was done through email or text. Daily step goals were defined by calculating the average number of steps taken per day during each week. Goals were increased if the participant met their goal on 4 consecutive days during the previous week. Each partner provided written feedback via email or text to either praise their peer for meeting their goal or provide encouragement to them to try harder to meet the goal the next day. A group call was scheduled at the end of each week for graphs to be shared. Each member had a copy of their graph to show during the group call and progress was discussed. Praise was delivered for meeting goals and increasing steps. If goals were not met for the group member that week, then encouragement was given for them to try and meet their goals the following week. The intervention was removed briefly to determine if the participants' daily step counts were affected by the removal of the intervention. During this phase, each member continued to keep account of their daily steps and put their daily count into their graphs. During return to baseline, group members did not report step counts to their partners, provide or receive written feedback, or participate in the weekly group call, or make graphs throughout the phase.
The results of our study turned out differently than the results produced from Nordman's 2008 study. While Normand found the intervention involving daily monitoring, goal setting, and feedback to be effective, we found our results to be highly variable and therefore only semi-effective. Our results indicated that only 1 out of our 5 participants produced a clear function of the intervention. Katie was our only participant to produce effective data from the intervention. Her data clearly showed an increase in steps during the intervention phases and a decrease in steps during the baseline phases. Our remaining 4 participants, Joanna, Lauren, Kendall, and Sarah, did not exhibit a clear function of the intervention, for their results were varied as there was no distinct increase or decrease between the phases. Here we have all of the participants' individual graphs depicting their data. As you can see, Katie's graph is in the middle on the bottom row, and you can see that while her baseline and intervention 1 data look a little similar, you can see in her baseline that her last 3 data points are decreasing, and that in her intervention 1 phase, while it starts out low, it majoritarily increases throughout the course of the intervention phase. Move on to her return baseline, and you can see that her data points drop significantly and then jump right back up in intervention 2 as she increased her steps. When you look at the remaining 4 graphs of all the other data, you can see that the points are kind of up and down and all over the place across all phases of the 4 intervention, or across all 4 of the phases of the study. And you can see that it's just very variable and therefore does not show a clear function of the intervention on increasing steps. Here we have the participant data table, which lists all the participants' averages and ranges across all the phases of the study. And again, if you look at Katie's graph, or Katie's data, you can see that her averages pretty well depict how she increased and decreased between the phases, where again, with the rest of the participants, you can see that their ranges and averages are very variable. As if you look at treatment 1, you can see the range of Sarah's data starts at 358 steps and then it jumps all the way up to 11,160 steps. So while she did increase steps during that phase, her data points are just all around very variable. Jumping down to look at Lauren's, you can see that in her baseline 2 average is 7,938, and her treatment 2 is only 7,901, which shows that she actually had more steps during her baseline than her treatment phase, again showing that there was not an effective intervention present there.
So next we're going to go through how we calculated the inter-observer agreement. This was done in 2 ways in this study. IOA was calculated to check daily step counts. This was done by a permanent product, which was in the form of a picture of the group member's pedometer. So each group member took a picture of their pedometer every night at 8 o'clock and then recorded that number in a shared table. The IOA was determined by comparing the numbers in the pictures to the numbers recorded on the table and then determining the percentage of step counts that matched the picture for that date. So the percentages were calculated by taking the number of days where the picture and the step count in the table were matching and then dividing that by the total number of days for the phase and multiplying by 100. So our results were perfect. We have 100% IOA for step count. All of the group members reported that they logged their step count each day at the correct time for every phase, and that was for every participant. So we had 100% IOA for step count for the entire project. The second type of IOA that was calculated was for daily self-reporting. So this was only applicable to the intervention phases where the self-reporting procedure was in place. During intervention 1 and intervention 2, each group member was responsible for recording that they sent their step count to their assigned partner, and then that was recorded on a shared table with all of the group members. The permanent product here was the text message that was used between the partners to show that the step counts were reported on each date. The IOA was calculated by taking the number of days where each group member reported their daily step count to their partner by the total phase. This was then multiplied by 100. All of the participants except for myself recorded data for that day, which resulted in an IOA of 92% for intervention 1 for my data. All of the participants' IOA scores for the intervention 1 phase totaled 98%, and then we had 100% IOA agreement for the intervention 2 phase. Treatment fidelity was also recorded. Each participant recorded their accuracy in regards to implementing each part of the procedure throughout the study. Each of our phases were broken down into smaller specific steps that needed to be completed in order for that procedure to have been implemented correctly. Each participant kept a table of the steps for each phase of the study and recorded their own performance. A percentage of accuracy for a procedural implementation was calculated for each participant by taking the number of steps performed correctly for each phase and then dividing by the total number of possible steps for that phase. Then that was multiplied by 100 to give a percentage. So our results were also very high, just like the IOA. 4 out of 5 of the participants had 100% accuracy with all of the treatment fidelity steps across all 4 of the phases. For myself, because of forgetting my pedometer resulting in no data for 1 day, I had a 92% treatment fidelity accuracy. So when that was averaged with the 100% across the rest of my phases, I had a total of 98% treatment fidelity, which totaled 99% for the entire group for the entire study. This is an example of the treatment fidelity table that each group member had for baseline. The only step of the procedure for this phase was just recording the daily step count and tracking it at 8 p.m. So you can see how each group member could track yes or no, or Y or N if they completed that step correctly each day. And then here's an example of the treatment fidelity table for one of the intervention phases. There's a few more steps on this one. So you have the step being tracked at 8 p.m. The steps were sent to that person's assigned partner that evening. Feedback was then received from that partner that evening. And then on a weekly basis, the partner would make a graph for explain that graph to them. So then you can also see how you could just mark if that occurred or not. And that's how we also kept track of each part of the steps for the treatment fidelity for the intervention phases. So we also had a social validity survey that each group member filled out after completing the project. This was designed to determine each participant's level of agreement with statements regarding the effectiveness and importance of the interventions, as well as everyone's satisfaction with the experience. A 5-point Likert scale was used where each participant could rate their level of agreement with 4 different statements. The rating scales ranged from 0 to 4, so a score of 3 or 4 indicated some level of agreement, while a score of 0 indicated complete disagreement with the statement. So our group created a social validity survey based on the description in the original article. Each group member filled this out after completing the project, and this survey included 4 statements. The 4 statements in our survey were: I believe that monitoring the number of steps I took each day helped me to increase my physical activity level. I believe getting daily feedback about my step count helped me to increase my physical activity level. I believe that seeing a graph of my step count and receiving feedback explaining the graph helped me to increase my physical activity level. And finally, I enjoyed participating in the study and I'm satisfied with my experience and my results. And here we have a copy of our completed social validity survey. So you can see here that each group member responded to each question by highlighting the number for their response. All of the group members showed some level of agreement when they were asked if they enjoyed participating in the study and were satisfied with their results. Also, out of all the participants, 4 of the 5 of them recorded a 4, which is the highest level of agreement with that statement. Although all of the participants agreed that they had overall satisfaction, there were varying opinions regarding each participant's beliefs about the effectiveness of the interventions. All of the participants reported a 1 or 2 score when asked if they agreed that receiving daily feedback about their step count helped them increase activity. So this indicates that all group members disagreed with this statement. When asked if we agreed with that seeing our graph of our step count and receiving feedback about our graph helped us to increase our physical activity, all of our group members except for 1 disagreed with this statement. Also, all of the group members except for 1 reported that they believe that daily monitoring of their step count helped them to increase their physical activity by scoring a 3 or 4 for that statement.
There are many limitations discussed by Norman that were also present in our replication of the study. Although 3 of the 4 participants in the original study showed an increase in step count and reported that self-monitoring and feedback was a successful intervention, our replication results were not consistent. Norman stated that goal setting was not an important component of success in the intervention. He suggested setting a weekly average instead of a daily average to compensate for days that a participant forgot to wear the pedometer or had a day where they took a lower number of steps. Also, there is no empirically established guidelines for setting performance goals, which could impact the effectiveness. This study used the average daily step total from the previous week to set the goal. However, there may have been a more effective way to set the performance goal. Norman also suggests that using percentile schedules of reinforcement would be more of an objective and quantitative way to adjust the goals. Feedback delivery was given on a daily basis. However, there was a lack of component analysis comparing daily feedback versus weekly feedback in written, vocal, and graphic feedback. Previous research suggests that daily feedback is more successful than weekly feedback on self-monitoring. However, for this study, weekly may have been more effective. Incentives are another way to motivate an individual to complete something they may not be motivated to do. They are proven effective in other settings and may have been successful in increasing physical activity amongst the participants. Our replication of the study came with its own set of challenges and limitations. All 4 participants used a different method to track their steps, including pedometers, Fitbits, and a Samsung Galaxy Watch. This could have caused some inconsistencies within each participant's total step count. We chose to stop tracking steps each day at 8 p.m., which meant a late workout could not be counted in the steps for that day. Some participants reported not having time during the day to work out because of work and school, therefore leaving them only the evening to get in their exercise. Our results may have looked different if we ended at a later time. Although we all agreed to replicate this specific study, we did not necessarily volunteer to do the project itself. Volunteering to do something usually indicates motivation, which is important with physical activity. Due to our busy schedules with work and school, we felt there was a lack of time to get an extra step some days. Also, some of the participants reported lower step counts during the week and higher on the weekends or vice versa. This impacted meeting the daily step count goals, which contributed to our unsuccessful results of the intervention. During the study, there seemed to be a lack of consistency and motivation, which could have been due to the intervention. Self-monitoring, feedback, and goal setting did not prove to be enough to motivate 3 of the 4 participants to increase their daily physical activity. Overall, our group concluded the biggest limitation during this study was life getting in the way. Juggling work, school, and families proved to impact our daily step count. Only 1 out of the participants saw an increase in physical activity from using goal setting, self-monitoring, and feedback.
In conclusion of this replication study, we found that obesity is a growing problem in the US, which is why studies like Norman's 2008 study are important in helping to find ways to increase physical activity levels in individuals to combat obesity. In our replication of Norman's study, we found his intervention involving self-monitoring, goal setting, and feedback to be only semi-effective, despite the fact that he found the same intervention to be effective in his original study. Our results indicated that the intervention was only semi-effective for only one of our five participants showed effective progress and displayed a clear function between the intervention and number of daily steps. Our remaining 4 participants produced varied data that did not display a significant increase or decrease in the daily step count throughout all of the phases, making the function of the intervention unclear. Our difference in results from Norman's original study to our replication study could have been impacted by the limitations of our study. We also discovered through our social validity survey that we as participants were not motivated by feedback, which could also explain why our results turned out differently. For any future individuals looking to replicate this study, we would recommend using something more motivating than just feedback so that the participants will be more motivated to increase their daily step count. This slide presents the question posted by our professor, which is, what were some unanticipated challenges and or something new you learned about ABA research through working on the behavior change project, in which we collaborated and came up with the following answer. Throughout the behavior change project, we were each awarded the opportunity to serve as both a participant and an experimenter. While serving as the experimenter, we learned the importance of detail and replication can not only increase limitations, but also cause extreme differences in data. In addition, we learned the importance of having stable data prior to moving on to a new phase. As participants in the study, we were responsible for a wide variety of components in the study, which included not only tracking our daily steps, but also remembering to text our partner daily. Multiple participants reported difficulty with remembering to wear their tracker daily, recording their steps at the correct time, and texting their partner for feedback. As a result, multiple participants utilized additional tools, such as alarms and reminders, to assist with ensuring treatment fidelity and integrity. The following are the references that we use throughout this study and project. And thank you for watching our presentation.